Hello, and for this presentation, I will talk about apple fruit calcium content. Here's a chart that shows the calcium accumulation in apple fruit. Here we have the calcium in milligram per fruit and fruit weight. You can see that there are two different or distinct areas in this chart. We got the phase 1 and the phase 2. During the phase 1 is when the fruit is undergoing cell division, which occurs sometime after bloom all the way to 5 to 6 weeks after bloom, right there. This is when the cell division stops and cell's expansion begins. The cell expansion will go and continue up until harvest. As you can see here, the calcium data is clustered together tightly during the phase 1 of the cell division. And the data for the calcium is a lot more scattered during the cell expansion phase. And I'll explain why in a little bit later. I am using Honeycrisp apple here as an example for these timings. Honeycrisp are generally considered somewhat of an early apple variety because it takes about 4 months from bloom to harvest. Now, Honeycrisp and other apple varieties is very common for people to sample fruit at this stage, at 40 to 50 grams fruitlet stage, and send them to the lab for fruit analysis of mineral content, including calcium. And the reason for that is, by the time the fruit gets to this stage, the cell division is done and is moving on to the cell expansion phase. At harvest, it's also very common for people to sample the fruit and send them to the lab for mineral content analysis, including calcium. In general, there's usually about 50% of the calcium in the early fruit compared to the harvest fruit. So it's pretty much a split 50-50. There's 50% of calcium content in here, and add another 50 and you got the fruit at harvest. This is a very general number for Honeycrisp apple. Here's the data that shows the fruit accumulation of calcium. As you can see here, fruit at 50 gram stage, on average, will contain slightly more than half of the calcium content of the fruit at the harvest stage. I've talked about the calcium accumulation in the fruit. Now let's talk about the calcium concentration in the fruit. During the early stage of the fruit, calcium concentration is normally much higher than that of the harvest fruit. Remember that we have the cell division occurring early on and cell expansion on the later stage. You can see the dilution of the calcium concentration as the fruit mature into harvest. We take the Honeycrisp apple for example. At the early stage of between 40 to 50 grams fruitlet, you may have about 9 milligrams per 100 grams fresh weight of calcium concentration, or approximately about 4.1 milligrams accumulated total of calcium in the fruit. Now let's talk about the calcium concentration of the fruit at harvest. We see here the calcium concentration of the fruit at harvest is generally much lower than that of the early fruit, and that's because of the cell expansion and the dilution of the calcium. But this doesn't mean that the calcium stopped going into the fruit. The calcium continued to accumulate into the fruit. It's just not quite as fast as when it went into the fruit at earlier stage. When we look at the fruit sample at harvest, you may have about 4 milligrams per 100 grams fresh weight of calcium concentration in the fruit, or approximately about 8.1 milligrams accumulated total of calcium in the fruit at harvest. You can see that it's approximately twice as much of that at early fruit stage. Here's a useful table produced by Yara based on years of research work. On one side of the table, you can see that calcium concentration in the 50 grams fruitlet. And on the other side of the table is the risk of deficiency in the fruit at harvest in percentage. For example, if your fruit analysis at 50 gram stage shows 5 milligrams per 100 grams fresh weight of calcium concentration, then you're 100% likely to be calcium deficiency at harvest. On the other hand, if your fruitlet analysis shows 15 milligrams per 100 grams of fresh weight calcium concentration, then you're likely not to have any calcium deficiency problem at harvest. It is a general rule of thumb that if you have higher calcium in the early fruit, you will also have higher calcium during harvest. But there are some exceptions. This chart shows the accumulation of calcium over time as the fruit gets larger. You can see during the first phase of the cell division phase, the calcium data is clustered together fairly tightly. But during the second phase, there's a lot of noise. What that means is that during the cell expansion phase, or the second part of the growing season, there are many factors that affects how calcium gets taken up into the fruit. And if you're not careful, you may have higher calcium during the first phase, but you end up having lower calcium during the second phase. There are factors like excessive tree vigor, overwatering, low calcium in soil solution, long period of heat, and many other factors that can negatively affect calcium uptake into the fruit. So while you do everything you can to get as much calcium into your early fruit as possible, that work would have to continue on to make sure that you have higher calcium at harvest as well. Thank you for watching this third part of the 8-part video series I'm making about calcium. Stay tuned for the next video where I'll be talking about how to influence your early fruit calcium.